Okay, so put this in your notes for convergent and divergent series. Okay, convergent and divergent. And these are all about series, so they're going to be separated with plus or minus signs. Remember, sequences are separated with commas, series separated with plus or minus signs. Okay? Okay, so if an infinite series, and they're going to show that by the 3 dots to show it continues on. If an infinite series has a sum or a limit, then the series is what they call convergent. They're going to go through some kind of terms or definitions, and then we'll go through some examples. If it's infinite, now notice it did not say geometric arithmetic, it just said if it's infinite and you can find a sum or a limit, then it's convergent. If an infinite series is not convergent, then it is divergent. Okay, it's divergent. And in order, you're going to start checking first, is it arithmetic? Okay, so an infinite arithmetic so that means it's going to have a common difference and it's going to have the dot, dot, dot. Spell it wrong. An infinite arithmetic series has no limit okay, so it is divergent. That's the first thing you check. Is it arithmetic? Okay, now highlight this. If it's an infinite arithmetic series, it's divergent. Okay, no matter what. Okay, if it's an infinite arithmetic series, it's divergent. Okay? After you check is it arithmetic, then you should check is it geometric. Okay, the geometric, and you always want to do these in order. The geometric series A plus AR plus AR to the second power plus, and then show 3 dots to show that you left out some terms, plus AR to the n minus 1 power, and then put a plus sign and 3 dots to show that the infinite part. Okay. Okay, that series converges to S equals A over 1 minus R. That was the formula for the sum of an infinite geometric series if the absolute value of the ratio was less than 1. Okay. Then it's convergent. So it converges to, and it converges to that sum if the absolute value of the ratio is greater than or equal to 1. It's no sum exists, so it's divergent. You might put in parentheses, no sum exists. So far, you're going to check on your series, is it arithmetic? If it's arithmetic, it's automatically divergent. If it's not arithmetic, then you check, is it geometric? If there's a common ratio, okay, you have to look at if the absolute value of the ratio is less than 1, then it's convergent, and you can find the sum. If the absolute value of the ratio is greater than or equal to 1, there's no sum, and it's divergent. Okay? Okay, so let's look at an example. Say they give you 1 plus 3 plus 9 plus 27 plus ... And they will ask, is this convergent or divergent? Okay, first you have to check, is there a common difference? No, so it's not arithmetic. Then you check, is there a common ratio? The order that you do this makes a difference. Common ratio, you have to check 3 divided by the previous term, 9 divided by the previous term, 27 divided by the previous term. Common ratio is 3. Absolute value of 3 is greater than or equal to 1, so it is divergent. Okay? Because the r equals 3, and the absolute value of r is greater than or equal to 1. So final answer is divergent. Okay? Okay. Any questions on that one? Okay, now, what if the series is neither arithmetic, you can abbreviate it, arithmetic or geometric. Okay? Then use the ratio test for convergence. You're not guaranteed that these series are going to be arithmetic and have a common difference. They're not going to be geometric and have a common difference. So then you have to use something else, okay? And it's called the ratio test for convergence. The author uses an R here. I wish they'd used a different. They used R because it's ratio. But this R is not the same as the R for a geometric series. Okay, the formula for the ratio test for convergence is R equals the limit, okay, and up in the numerator, it's a sub n plus 1. Oh, sorry, wrong. I wrote that wrong. A sub n plus 1. Sorry. Got to read my own handwriting. A sub n plus 1 over a sub n as n approaches infinity. Okay. Make sure you corrected this. Put that plus 1. It's n plus 1. It's a sub n plus 1 divided by a sub n as n approaches infinity. Okay? We will work some examples. If the r value, notice on this one it's not the absolute value, it's just r. If r is less than 1, okay, it is convergent. If your r is less than 1 on the ratio test for convergence, it's convergent. If r is greater than 1, it is divergent. Okay, and then the kicker on this one, if r equals 1. Okay, if you go through the ratio test for convergent and r equals 1, then the test fails. Okay, and then you have to try something else, and we'll go to that in a minute. Okay? Okay. So, let's look at an example. Okay. On this one, they actually tell you to use the ratio test, but they may not tell you. And if they don't tell you, you got to go in order: arithmetic, geometric, then the ratio test. Use the ratio test. To determine whether each series is convergent or divergent. Okay, and here's their series. 1/2 plus 2 over 2 squared plus 3 over 2 cubed plus, then put in a plus sign and 3 dots to show you we left out some terms. Okay. Okay, and on this one, the author may or may not give you the formulas. Okay. Let's say on this one I don't give you the formulas. Okay. When you use the ratio test, the R equals the limit of a sub n plus 1 over a sub n as n goes to infinity. Now you have to figure out, first you have to figure out a formula for a sub n, a general formula for the terms. Okay, what I do on this is I go back up here and I say n is, this is the first term. Do this with me. Do it on your paper. N is the second term. N is the third term. Okay, now look, I need to write a formula over here, a general formula for a sub n. Okay, compare this n to the numerator. They're the same, aren't they? Okay, so I ought to be able to say that the numerator is n. Okay. Now, how can I write a formula for the bottom? This is 2 to the first, 2 to the second, 2 to the third. What can I put down there? 2 to the n. Yep. So that is my formula for a sub n. You've got to find that first. Okay. Then, everywhere you see an n in that formula, you need to substitute in an n plus 1. Okay. So if I substitute in an n plus 1 for n, that'd be the next term. Substitute in an n plus 1, be 2 to the n plus 1 power, and then you need a plus dot 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 to show it continues on. Okay. Okay. And I would label that. That's the a sub n plus 1. Okay. Okay. Kind of see how we got the a sub n? That's the critical part. You got to get it first. Okay. Okay, then we'll go back down to our formula. You need an equal sign. You still need the limit notation. We need the a sub n plus 1. So we need this fraction, the a sub n plus 1 divided by this fraction. Okay? So you got to write out a complex fraction. It's n plus 1 over 2 to the n plus 1 power. Make sure you can read your own handwriting. Divided by n to the 2n power as n goes to infinity. What's the rule to divide by fractions? Yeah, invert that second one and multiply. So we've got to invert this one. Okay? So still need an equal sign. The limit. Okay, n plus 1 over 2 to the n plus 1 power times, we need to invert this fraction, so it'd be 2 to the n power over n as n goes to infinity. So all I did was invert that bottom fraction and change it to multiply. Okay? Okay, now we have to simplify that. Equals, still need the limit symbol as n goes to infinity. Okay, now we have to simplify this part. When you divide, if I look at an example. If I had something like this, x to the third over x to the fifth, when you divide monomials, okay, and the bases are the same, what do you do with the exponents? Subtract them, okay? So if I divide these monomials, the bases are both 2, I subtract the exponents, what's left? Or another way to say that is, do this outside on your scratch work. If I do this, if I simplify this, this is actually 2 to the n power. This is actually 2 to the n power times 2 to the first, right? Because if I multiply those, I add the exponents. Now divide. 2 to the n will divide out with 2 to the n. What's left? A 2 on the bottom, right? 2 to the first on the bottom. Okay, so if I reduce this, I still have an n plus 1 here. I would have a 2 left here. I would reduce this, and there would be a 2 left. And I still have 2n, right? Right, subtract these exponents, the large ones on the bottom, so I'm going to have a 2 to the first on the bottom. This is still left on top. This is still left. 2 times n is 2n. Okay, so now calc shortcut what we did. Okay, this is an n to the first, this is an n to the first. What's the limit if the degrees are the same? Ratio of the leading coefficients. So it's understood to be a 1 there. So the ratio of the leading coefficients. So the limit is, now this is where the limit notation disappears. And I can just say the limit is 1/2. Okay? That is actually my r. R is 1/2. That r is less than 1. Go back up to the notes. Convergent or divergent? Convergent. Okay. Okay, so you got to go through all that work to figure out that that is convergent. Okay. Any questions on that one? Okay. Let's look at another example. Example 2. Okay, say they give you same directions. Okay, here's the series. 10 over 1 plus 10 squared over 1 times 2 plus 10 to the third over 1 times 2 times 3 plus ... Now, sometimes the author may give you, but I'm not being nice, okay? You have to figure out what is the a sub n, okay? I always start out, n is, this is my first term, you'll always start with 1. This is my second term, this is the third term. What can I put for the numerator? 10 to the n power. What about the denominator? Where does that denominator stop? Stops at n, doesn't it? Stops at n, stops at n, stops at n, right? So if I just show the pattern, 1 times 2 times 3, ... on up to n. If that n was 8, it's going to go 1 times 2 times 3 times 4 on up to 8. Okay? If it was 9, it'd stop at 9. Yep, you could put a factorial. In factorial, yep. And then you got to work with the factorial when you're reducing it. Okay? Okay, once you get your a sub n, okay, then you got to get the a sub n plus 1. So you got to go one more. Once you get this a sub n, you've conquered a big part of the problem, because now everywhere you see an n, you're going to substitute in an n plus 1. So what's the numerator? Yep, 10 to the n plus 1. And then this is going to go 1 times 2 times 3 on up to n plus 1. Now, if I said this was 3 and the number in front of it was 2, how do you get from 3 to 2? Subtract 1, right? If this is n plus 1, what's understood to be in front of it? N. What's in front of that? N minus 1, n minus 2. You can back it off as far back as you need to go. Okay? And then it's plus dot 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 to show it continues on. Okay? Now we've got our two formulas. Okay? So the formula R for the ratio test for convergence. R equals the limit of a sub n plus 1 over a sub n as n goes to infinity. Okay? Still need that limit notation and the equal sign. Okay, we need this fraction divided by this one. Okay, so let's put this fraction in first. 10 to the n plus 1 over 1 times 2 times 3 dot 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 on up to n plus 1. Now, I can shortcut this. If I said I'm going to divide by this fraction, invert, multiply by the reciprocal. So put the 1 times 2 times 3. I'm actually skipping a step, make it a little bit shorter. On up to n, and the bottom is going to be 10 to the n power. Okay? Now you have to reduce that. Okay, let's reduce this part first. 10 to the n plus 1 divided by 10 to the n. What's left? 10 to the first, where is it at? It's up in the numerator, isn't it? If I reduce this, 10 to the n, and reduce this, 10 to the first is up on top. Okay? And you can split that up if you want to. 10 to the n times 10 to the first, the 10 to the n's divide out. Okay? Now you have to look at this part and say, which one of those is bigger? The one on the bottom, right? Because it's n plus 1. That's why I back it off. What's the one right in front of it? An n. Okay, now reduce it. Okay? Reduce this whole thing, divides out with this. What's left is this n plus 1. Okay, now I still have that limit symbol, the equal sign. All I have left on top is 10 times 1, right? All I have left on the bottom, n plus 1. If there's no n up here, it's actually n to what power? N to the 0. And this is n to the first. Now you go back and use your calc shortcut. The degree is less on top. So the limit is 0. Convergent or divergent? Yep. R is less than 1. So it's convergent. Okay, so it is convergent. Go through all that, figure out it's convergent. Okay? The calc shortcut. If you go back on the calc shortcut,